Hello and welcome back to another session of Google.rs. It's Byron speaking. And after a little break that probably wasn't as little as I advertised it, I'm back with something that didn't really go forward an inch last time I tried. In the meanwhile, I tried a bit more and, kind of got some ideas. I don't know if these ideas are going to be smashed in the moment I try to actually apply any of them, but let's just see. So this is, I'm still trying to figure out how this whole freshness thing is working. I think I have a basic understanding of how the work queue works, but after all, I still need to be able to lock a resource, and then after locking, figure out if it's already up to date, and if it is, do not engage, which is especially important when compiling and the likes. With the waiting lock configuration, this would mean that we would only compile ever one thing at a time. And I think that when compiling, by default, what will happen, there's this rustc function here as well as rustdoc, but rustc is what I'm concerned about right now. Rustc will call this add plugin depth, which will do that and add plugin, kind of emit information, emit dep info, emit link. Let's actually have a look at rustc. Rustc emit help. I don't know if that works. Nope. So emit. Look at that. Dep info, comma separated list of types of output for the compiler to emit. So we have plugin and dep info. Cool. Plugin is not listed, but I think this can be enabled by showing the unstable stuff. How can you show unstable stuff again? This does work. Yeah, because it also doesn't show the pretty output that it actually has. Maybe it's part of the Z thing. Yeah, it doesn't matter really. Important is that it does exist. Yeah, see, there's no pretty here. This is why I always look for it when I need it and never find it, because it's actually not officially there. Print the full set of options rustc accepts. Maybe this is what I want. Help v. So still no plugin here. Go file name outdir explain test codegen verbose. Oh, did I see the color thing last time? Yeah. Anyway, so dep info is part of the default output, it seems. Yeah, which is part of the prepare rustc, and there's no condition there, so it always happens, right? Right? No. Build plugin args. Yeah, so far, so good. Yeah, it seems that this always happens, huh? Yeah, outdir, where does it set -o? Here for rustdoc. Interesting. Yeah, I also, just for the fun of it, made a debug run which, how big is that? Quite a bit of output, just to see additional things maybe that might be interesting. Ah, look, that's the graph. Resolved graph. That's the dependency graph. Okay. Oh, is already activated. Yeah, I think this activated thing, this happens in the cargo log file, but it might be wrong, because that is totally related to the resolver. And the reason I'm into this is that there are these cargo log files that you probably want to protect as well. Feature information. Very nice. Yeah. And then there's plenty of information. I would wonder how this is being produced. So fingerprint, that's lib time. And it gives me that. Checks it again. And that's probably the fingerprints of inputs, whatever that is. What is that? Well, it only provides, yeah. Why is there a way to provide more output here? I mean, is it really necessary for me to dig in there? Inputs. Known self extra. Yeah, it doesn't tell you which package it works for. But I think it's good to have a log just to see in which order stuff is executed and where this relates to in code. And this is the only place where this happens. So yeah, inputs, then this is known, then self extra. Okay. Then depths, no dependencies, and then the output resolved. Okay, and that happens a lot. Yeah, so my question was, what's this output here? How is that computed? And yeah, on which side is that? I think that's on the output side here. Yes, so that's resolved. Short hash. From all this, I see. So from known, self extra, and dependency, it creates the short hash. And if any of this changes, then the short hash changes. I think that's what it wants to say. It would be interesting to understand how such a file is created when such a file is written. I thought I have seen it somewhere. So that's rewriting of the dependency file, and that's the fingerprint as bytes, but this is part of a work unit. Is fresh. And returns a preparation. Yeah, I know that. That's a tuple. Fresh, dirty, right fingerprint. So if it's, that's the fresh one, and that's the, that's the dirty one, that's the fresh one, right? And this fresh is given to us. So yeah, and the fingerprint is what we are getting here. which is written at this location. So the location is computed by some other hash that I also don't know how that works. Yeah. So, long story short, maybe I try just somewhere. So the Rust C stuff seems to be where most of it happens and where things can go awfully wrong. Because when compiling, I get these errors. So what if, let's see job new. So this happens here for the fingerprinting. And I think the fingerprinting, deals with the dependency files. And I think if it has to create one of these files, I think if it has to create one of these files, then the compilation will happen anyway, right? Work call dirty. So this is kind of a combination of work and I wonder, so this is, where is this coming from, this work? For work and work into either. Damn it. I don't know where that is coming from. If profile doc. Why does work have into either? Because it's a vector. So here we go Rust doc and here we go with Rust C. So that's the primary package generator. And it's supposed to be a vector. So Rust C produces a vector, right? Let's verify that. Maybe I want to have another one of these. It's actually in Rust C. Rust C mod. Yeah, a vector of work of a certain kind. And the kind, I think, was host and target. So this one is just preparing stuff. And here per Rust C that it wants to generate, and this is also, I think, per target or dependency where you then get stuff. Let's see, prepare Rust C. Where's the loop? Is there a loop anywhere? Cargo result, yeah, that already returns a vector of command prototypes. Oh, it's really just a tiny vector. Target command, host command. If it's a plugin, it's a host command. I see, that's just for plugins. Plugin and target. Okay, if there is no target, then it's just one, and if there is one, then it provides you with target command and host command, and that's the vector then. Okay, for each of these work units, you load additional stuff. Where are the plugin depths going? Here. So you iterate it, and then you set each one up. You kind of finalize the call, I suppose. Then you set up a work unit, which is just a single unit, which probably assumes that it is dirty because it doesn't care. It just prepares it. I think whether or not it will be run is depending on the fingerprint eventually. The freshness of the fingerprint that we get here must at some point be, useful for something. What is this? Not that I have the capacity to care, but damn it. Oops. That is actually not a valid link. If you look at it from here, but it should become one like this. But it doesn't actually write output if rerun quickly. So that is fixed. Oh, is this something I've noticed before? File removal. Yeah, I think I've noticed that before, but hey, not what we came here to do. Yeah, so within this work unit, it adds even more to the command, which will provide dependencies as well. And then it executes the rustc command. It would be interesting to know what output is expected. So that we can log here maybe. Yeah, so that we can log here and then check for the output. Maybe even create a log file that has the name of the output, because we will not truncate or do anything with it. Oh, no. Actually, do you want to tell me that go-to-definition just did something useful? Wow. Not bad. Not bad at all. Cool. Control Alt D. Shift D. No, doesn't do anything. Oh well. Oh, it's Nimrod go to definition. Interesting. And the one provided by the text editor doesn't seem to be working as command. Yeah, that's something to look into, I guess, because that could be useful. Chain error. Yeah, that works for me though. Okay, anyway. So this is the part where you want to know what kind of output do and real name and not crate name. So here it does that, right? File names 0, where do we have the file names? Destination. It removes all the destinations. Destination with file name. What's with file name? Is this changing the file name or what? Because I think that's... yeah, changing the file name. File name unwrap to string. Unwrap, replace real name with crate name. So that's the source. And rename, fs rename, is this is like a move, huh? So that will also move along across folders. Fs rename, show me. This will not work if the new name is on a different mount point. Ah yeah. So it's using the file system move. Okay, interesting. So it's a low-level I/O operation. Yeah, what else did I expect? I think in Python, it will actually copy everything. Just manually. So anyway, the renaming here, yeah, if has, this is, if not has custom args, and if meta, I don't know why that is important, but I have no understanding of this anyway. And if there is a rust-c dep info thing, then we name this into the dep info. I think the rust-c dep info is in depths, and it has the extension .d. And the dep info log is the one that is it's called usually dep lib and then lib name. And it has some additional information in it. It's a fingerprint that can be used. And this happens on a per compile basis. And they check if it exists. So yeah, I think if you would know the output here and or something and lock it there, then you should be good. Then you wouldn't have to call the actual rust-c thing. And I think this is what I would try. And the dependencies, they are, yeah, interestingly, they're just they're just rewritten. Yeah, I think that's fine. So one thing, where is that coming from? If do rename, then we put into root join crate name. Otherwise, it's in file stem package target profile, but it has the extension .d. All right, and that's created by the fingerprint. Okay. So the output, the expected output. I'm not, how do they do it? Yeah, the file names.iter. How is that set up? Target file names. Huh. Okay, but the out tier is the root, so I think I can just actually log this and then see if any of the file names exists. And if or if all of the file names exist, then we will do what we want to do. Has been lots of activity in this pull request. Cool. Actually is very fast in merging. This shouldn't be merged. Anyway, let's, yeah, I think I got it. So do we have a config here? Context, right? The context has a config. Context config, which we can query with. Give me the config. Oh, it's pub. Good. So it's context config. Good. So we have everything we need to set up the lock. So set up the locking right here. And that should really help already, even though we have to do the cargo lock stuff in case we want to have the same package. And I think that should be it already. I'm curious if it will be that easy, because it all happens on the work queue. And, you know, the actual question is, and this is something I still have to understand before I do this, just to be sure. This Rust-C work, it shouldn't be scheduled if the fingerprint says it's up to date, right? So this happens here in compile. So here we have the fingerprint stuff. And it should at some point give us some freshness. And tell us, that's just preparing the directories. That's nothing. And we also don't lock that one yet, but we might. So dep info lock. Oh, that's in Rust-C already. That's also Rust-C. Interesting. So here it is fresh. This is important for prepare. There it will, whenever it resolves the fingerprint, I think then it will check for freshness, kind of. Well, is fresh is probably the most important thing. Prepare target is fresh. And this freshness, does it matter? Let's compile. So for work, the work ID we get from the Rust-C thing. So yes, here it does matter. So that's the prepare target. So here it determines if we need to compile, right? That's the important one. Sorry, that's the freshness here. Job new, dirty, and fresh. Dirty will do the actual work and then call dirty of the prepare fingerprint target stuff. Yeah. It would really help, I think, if the variable names would be a bit more descriptive, wouldn't they? Gee. So that's the dirty of the fingerprint here. And that will basically update the fingerprint once it was created by this work. And this is the work we get from Rust-C. So basically, here, in the dirty case, we would possibly have to lock and check something. But this comes after. So yeah, I think in this target root, where stuff is going into, which is the depths directory, which should be the root here, out there. Here we put one lock, a Rust-C lock. And this is what should lock everything to the point where it will work. And we might have to check this dirty one as well. Prepare target, dirty. Yeah, the dirty one will just rewrite a file, huh? Well. Yeah, it will just rewrite the file, and it writes it with a fingerprint that was computed. And there's probably no harm in rewriting it. even though technically we would have to lock that file. The cool thing is we can obtain a file lock it for writing, and then write the stuff, and we are safe this will work. So I think, yes, whenever we do an F write, we can basically get a free lock. Because here we do open new, read true, write true. Oh, it reads the contents. Yeah, the read true, write true thing. Yeah, we could open it twice maybe. Oh, we need a different log file, damn it. So this reading thing is something we couldn't support. Anyway, for one thing here, at least we can do the logging, right? Even though we do not have a lock kind here just yet. And I think the configuration, oh, here we have a config. So yes, we could do it. We can just provide a lock kind. I'm digging in too deep, I feel. Just checking. So we have a context around in all the cases where this is called. Yeah, so we can do it. Because the context has the config, which is what we need to determine the type of lock. Okay, so I think that's it. Let's use this. Util config. Chain error we have as well, that's good. Cargo lock. And a lock kind. Do we need it? I don't think we need it. Yeah, that's the wrong registry again. I think it's this one, huh? Yeah. So that's the piece that we need. And the point is that we remove the destination files only. Yeah, well. Now we get into the point where we have to do this. You probably shouldn't have to do this manually. So yes, maybe I invert it and say, well, what if the file names are there? And if they're all there, we are good. And we don't do anything. I think this is what I would want to do. Otherwise, yeah, so let's do this. What does this return, by the way? So we can try here. That's interesting. We can try here, and we can do all the fanciness with chain error. So we can do what we just pasted here. So that's cool. So self, sorry, not self, it's root join. And that's a RASC lock. And cargo log, where's the config? Oh, it's a CX config. That's the one. CX config. Here we get the lock accordingly. And we are done. So now we try to lock it. Fail to lock. Compilation off. And now it would be useful, I guess, to have information about the package that we want to do. Profile package. So I guess I can just do this. This worked before, provided I format this. Here we go. Yeah, so that should work. So, well, now that we have a lock, check if all the files exist. If so, another collaborating process will have created them. Note that we only get to do this if we either waited on the lock or got it ourselves. Oops. Without waiting. In the latter case, we wouldn't have to do anything yet, but can't differentiate one case from the other. That is true. We just know that we can now safely do stuff. So I think I can do this all, and then it should create get a closure f with an item. Test whether the predicate holds true for all the elements in the iterator. Yeah, all, and then that's the file name. And then we just return. Yeah, actually, I probably want to have this. And then we... maybe not. Root join file name creates a new thing. Then we can put this in here and do this. Let's see how that looks like. Okay. So maybe we will then just put it here. Like that. So that's kind of the style I got used to now by looking at the code. So if this is true, then we are done. Maybe I can squash it in there somehow. Yeah, let's try it one more time, because then the if would look better. Actually, I can. No problem. Perfect. Yeah, that's fine. So then we are done. Everything has been created. And there is the possibility that it's a leftover from the last one and you want to update the same files. But on the other hand, if you look at it, we always create files with a hash in there, so there cannot be a leftover unless there was a partial build or something and the build aborted. And this is a danger, of course, but I think if the build aborted, we will not have all the files. Well, possibly we have all the files and one is partial, so that's a possibility to do. Is there a way to verify the contents of the files is valid? Is the previous operation of them they're aborted? This might just not be the case. Yeah. Could indeed be. And we have no way to find out safely. So grabbing a log and getting this, I mean, this is the only call that is good for us here. This is the only call where we know that this is a definitive synchronization, a barrier. Everything else we do with files is not guaranteed to be atomic, so we can't really rely on that. But anyway, for the most part, this should do. So once the execution is done, we are still doing stuff. We are not releasing the lock until all of this is done. This is what we do. Okay, so let's see if that compiles. Make. Updates the registry again, thank you. Yeah, that could actually work for us. This could work for the multi-dependency case. J2. This is what we want to try then. Actually, this target I want to remove. Yeah, so once cargo is ready. Oops. It's not implemented for... Yeah, I think it's the file log stuff. What did I change? 378. So in order to move there, oh, now I get it. I think we can't use config because of the hash map, because this is sent to a... Yeah, I see. So in order to do this, it's sync. So we have to we can't do the cargo lock thing here. We have to get the lock kind like this. We have to prepare that, as they prepare everything here for good reason, right? Lock kind is this one. So that should have a better chance to work. Let's see. No. Configured variable package does not outlive the enclosure closure. Captured variable is valid for the anonymous lifetime defined here. Oh, I'm doing this. Do I have a package name or something? Yeah, that pkg name b format pkg. So that's just for the error case, right? So that should work. How do they do it? Could not compile name. Okay, so they do it like this. I shall just use name as well. Good. Better. Could not rename, yeah, blah, blah, blah. So I think this is what I want to do here. All right. Oops. Layout doesn't use human. Layout 53. I think I should remove that right away. Shouldn't have stayed in there because it actually doesn't compile. It just compiles because I have a hacked lib.rs here that allows a few things that are resulting in errors otherwise. Yeah, something new. Yeah, I like it. Let's answer that right away before I play a game while it compiles. Oh, it's actually done compiling. Nice. So yeah, let's answer that next time I compile. And now I'll just go ahead. And now the compilation should lock. No, it doesn't. No. So that didn't help. That didn't help at all. Is there some debug about to run? There's some debug stuff. We might just say rust log is cargo debug, and then we put it to 1 and grab C5 or 10 about to run like this, huh? Let's see. Actually, it is about to run. We might want to put it... Yeah, maybe this never holds. Maybe this doesn't work. Oh, because it will rename the files. It will move the existing files around. So whenever we want to compile... Let's check the freshness again. So here, dirty, fresh. Yeah, if it's fresh, it doesn't run the compilation. Otherwise, it does. So we have to figure out a way to prevent the compilation from being done. And we might actually want to check the destination. Yeah, so this doesn't work. It's just that this simply doesn't work. So this comes here because now we're actually running it. And the build state stuff. And I think this is also something we can drop down here. So here it set it, and then we prepare it. And this is how it would be. But it doesn't change the fact that this doesn't work. So now we have a lock. Interestingly, yeah, that's a bit weird as well. We are locking this stuff now. Yet we have a problem. So what's going on there? Is it kind of other tools that run later? Okay, what happened exactly? Let's try to do it again. And also, let's check. Okay, we have 50 minutes in, so probably we should call this a session in a moment. So here I would expect a lot of... Oh, yeah, so it's just... Now we can just do one compilation at a time when it's about this one, right? So that idea is total nonsense. This will not work. That's the root where we compile stuff into. So it's kind of the rlib that is important, is it? But sometimes it's also... No, wait. This .o stuff, I think it's the C objects that it might compile. And I'm not sure if it does that in the same step. Probably not. It's a kind of a separate step that might as well be encoded here. Yeah. Still, in theory, we should have put everything into lockstep here. And yeah, I don't know about the expected output even. Except that all of these obviously should be there. Once, oh yeah, but once one guy has run. Yeah, the thing is they should still be in lockstep. Damn it. I do not get it. So that doesn't work. Not at all. So what kind of errors did I see? Okay, so here it compiles it twice. Could not copy this one to this one. So this could not copy. This is something, this is new, I think. I think it actually does compile it one after another now. But kind of gets confused. Oh. Jesus Christ. Now it gets, that's actually the important part. That's the part that is a bit more difficult to get to work. Okay, failed to remove. Who says that? Nobody. Cargo doesn't say that. Could not copy. Failed to read bytecode. Failed to read. Nope. Look at that. That's Rust C in action here. Failed. Could not copy. Open SSL. Compiling. So when is it even saying the compiling stuff? Damn it. Here. And job queue. Really? The job queue says that? Wow. Huh. In general, we try to print compiling for the first non-trivial test run for a package, regardless of when that is and then don't print out any more information for a package after we printed it once. I see. Any dirty stage which runs at least one command gets printed as being compiled if commands run equals 0. Otherwise, do this. Yeah, so if printed contains, then we don't print it again. So this is where it happens. And how does it know this thing is being compiled? Is it based on the stage? Fresh if stage is fresh. Stage end. And then it says fresh. Does it say fresh at some point? Did I see this? I think I've seen this sometime. Now this is actually where I want to be. Shit. I have the feeling that I'm not getting anywhere considering my lock there is so brutal and it just doesn't work as expected. Does the work queue know anything? That one, after all, does the stuff. Maybe I can lock that down. What do you know, my dear job queue? I think you know a lot of stuff, do you? But at the end, you just know as dependencies. It knows very specifically what kind of stuff is going on here. Start job, job, run. That's a self-run thing. So here is the information it knows about something that is supposed to be run. That's the job that it will execute. Yeah. Damn it, I'm still not anywhere. Still doesn't work. But I think the errors are now different. It's just Rust C stuff. Because that in fact is not an existing file. Could not copy this one to that one. Target debug depths open SSL. What is it? This one. To that one. Both do not exist. But metadata does. Failed to remove. Then wants to remove it. Let's try to, I changed the code a bit. Probably doesn't change a thing. Oh no. Probably doesn't change a thing. Yeah. And I wonder, let's try it single threaded. I have the feeling that maybe now that we don't remove the files anymore, it's broken anyway. We should also run the tests. So then falling sand, I guess I can play a little game here. In the meanwhile, this one. And I should also resort to make and say done. Just so that I know exactly what's going on. Oh, see, now it's done. Okay, let's try that again with J1. Let's see if that even works. Yeah, and also with J1, I think I'm fine with just discovery to see if that works. In the meanwhile, we can run make test here just to see. Maybe it all breaks, then we know that probably we're out of luck with this. All right. That will take a while. Yeah, it's amazing that the scoring system here is so broken. 1,500, how did I do that? Yeah, I think speed is your advantage. When you try to go slow on that stuff, then they easily lock you in. Actually, this is something. You can go out of the thing and hide. Cool. Look at that. I didn't know this. Oops. That's the way to do it. It's kind of defeating the game. Oh, I think you get more points the longer you are inside. Is it? Yeah, I think so. And the faster you get to them, or the longer you are inside. I don't know. I don't know how I got the 1,500 there. So apparently compilation works I don't know if these guys give you extra points. Oh, I failed. Yeah, it seems to be also a function of time. Damn it. I would like to write this game in Piston. This could be my first little Piston game. It's simple. It's fun. Has some addictiveness to it. Rounds are really short. Oh. And there's probably some things you can try out, especially with the scoring system. I still don't know if these white things do anything to your score or not. Oh, that didn't work. Still compiling hypermock. Yeah, let's have a look at the tests in the meanwhile. 21 failed. No good. What the heck? Whew. But failed. Yeah, I think this is totally the stuff that we removed. This remove all files thing. This is what makes the test fail. Yeah. So this can't really be removed. Because if you do, maybe there's something else. Freshness. Yeah, I think this is related to the freshness. It needs to remove this for the freshness to work. Yeah. Okay. Got it. Diff current file. So there's actually no need to fix this. So if everything is there, fine. Oh wait. If everything is there, fine. Otherwise, remove everything. Something like it. You know, right now I'm hacking, but I'm not going to push this anywhere until it works. Obviously. Need to remove all intermediate files. Otherwise, freshness computation will not work as expected. Okay. So, in any case, cargo should be lockstepped here. This worked fine. We can remove this again. Just make cargo again. Make cargo and say done. And then try it one more time. Maybe we would also want to test this stuff. Make test at the end. But in any case, here we will do the J2 thing once we are ready. Oh, still alive. How did that work? Where did I run into? Didn't even see it. Yeah, there are lots of possibilities. You could do nice graphical effects here. Kind of some motion blurry stuff. Okay. It's done. And my score freaked out again. So, it's running the tests. Good. In the meanwhile, we'll see how this super locking works. In the end, we will rebuild everything all the time. But it should not fail anymore because it doesn't do it at the same time. Possibly this copying stuff that fails also wants to be locked. And yeah, we're kind of removing... Okay, there we go. But it's always the same. I think what happens is that somebody checks if this stuff already... Maybe it's us and we do not fail. Maybe we do not fail. Maybe we do not fail. Why does it compile target cargo again? Anyway, maybe this actually works. Maybe we should just run it and not care about it. Because if it compiles again, fine, but it at least will work. That's the point. Obviously, we have to get a log file that is named after the crate, because right now everything is in lockstep, but it doesn't matter. If that works, then we kind of duplicate the work, but at least it works, right? And this is what we want. And then we have one case done, even though that is really up for improvement, but I can probably rely on the people in the internet who wrote this to help. Oh, it's interesting. So stuff fails now. A lot of stuff. Gee, but it could also be related to the log file that is now in there. It probably destroys everything. Yeah, so let's not run the tests. They will have to be made to work. Okay, I guess that doesn't work. Okay. So let's just try it, right? So we lock the thing to the death. This really removes every kind of parallel processing that we had, which also works, right? This does work. We just don't have to or shouldn't do the same thing. And probably we also shouldn't abort. We should just go through with it. And if compilation is scheduled, we will, if necessary, just compile the same thing again. Yeah. Maybe there are some additional steps that are scheduled that I don't see here with AR and copy and whatnot, which then causes this to fail. 1 hour 10. Should probably finish this up soon. Oh. So, try it. Now we log everything, but recompile if needed. The rest of the code is the same. In theory, it will recompile that work. And let's look. Oh, processor usage actually tells it's doing a lot in parallel, which is interesting. It's doing a lot of stuff. And it has the same errors. Oh. No, wait. Unstable library feature. it pulled in maybe a new... Okay, that's something else. Maybe it just doesn't compile anymore because all of a sudden rand got unstable. But besides that, it still has these issues. And it does compile successfully with a lot of cores. Totally. Yeah, so I call this a totally failed experiment. No doubt about it. Maybe the locking should be... Oh. Maybe the locking should be in the queue. Instead, maybe I could just lock by package whenever something happens on a per package basis. Yeah, I could do that. Whatever happens, I get a lock. I could put it into the cargo home or somewhere where I know it exists. I could do that. Yeah, let's consider that because that just doesn't work. So, thanks for watching and have a great day.